Welcome back to it. It's Maths Masterclass with Leo. Today we are doing one of the nicest topics, which is actually the system of equations, right? System of equations. Some of you know it as simultaneous equation, but this is a system of equations. We're going to be solving the simultaneous equations using matrices, right? Solving the system of equations using matrices, right? For example, let's say you are given 3x plus 5y minus 7 is equals to 0, right? And then this is 4x minus 3y minus 19, this is equals to 0, right? We're used to solving it making either x or y the subject of the formula, but in this case we're going to solve it using matrices, right? Using matrices. It's a very simple chapter to follow. It's very simple. Okay, the first thing to do is to transpose this constants to the other side. Then means I'll be having 3x plus 5y is equals to my constant 7, and then 4x minus 3y is equals to my constant 19, right? And then after doing that, I can write it in terms of matrix form, which will be 3, 4, 5 minus 3. Then x, y. This is equals to what? 7 and 19. That is how I write it in terms of matrix form, right? Rewrite it in terms of matrix form. That is what I'm going to have. Then after doing that, after writing it in terms of a matrix form, we need to determine the inverse of this, right? We need to determine the inverse of this. Why? So that when we divide, because actually the reason for us to determine the inverse of this is to remove this guy. To remove this guy, right? Removing this guy means I must get the inverse of that. It's more like dividing by. But you'll see, okay, how do I identify the inverse of this guy? I have that guy, which is 3, 4, 5, and minus 3. Simply because this is a 2 by 2, I can interchange this and that, then change the sign for this and that, right? Interchanging this and that, I'm going to have negative 3, 5, 4, and 3, right? After interchanging this must have opposite signs. So that will be negative and negative, right? But I'm not done. Remember, this is a cofactor, right? These are my cofactors. Now, after getting my cofactors, I need to do what? I need to get my inverse. So my inverse will be what? 1 over the determinant of the original function multiplied by my cofactor, which in this case it will be what? Negative 3, negative 4, negative 5, and 3. Right? So I need to identify my determinant of the original matrices, which is going to be, in this case, my determinant will be 3 into negative 3 minus 5 times 4. Then this will be negative 9, negative 20, meaning this is negative 29, right? So my determinant is negative 29, so I substitute it there to get my inverse. 1 over negative 29 into negative 3, negative 4, negative 5, and 3, right? When I multiply this, 1 over negative 29 multiplied by 3 is going to be positive 3 over 29. Then 1 over negative 29 multiplied by negative 5 is going to be positive 5 over 29. Then 1 over negative 29 multiplied by 4 is going to be 4 over 29. Then lastly, 1 over negative 29 multiplied by 3 is going to be negative 3 over 29. That is my inverse. That is my inverse, right? Therefore, I have my inverse. After identifying my inverse, this is my determinant. Let me erase it. After identifying my inverse, what do I do? Okay, I'm gonna say here I'll have my inverse 3 over 29, 4 over 29, 5 over 29, negative 3 over 29. This must be multiplied by this so that we can remove this guy. So this will be 3, 4, 5 minus 3. Then I still have my x and my y. What I do on my left hand side, I must also repeat it on my right hand side. I have 3 over 29. I have 4 over 29. And then I have 5 over 29. I still have my negative 3 over 29. Let me erase this guy. This is how I identified my inverse. We erase it so that we can have space. Then, multiplied by what? By 7 over 19. Right? In the previous video, if you checked our previous video, you would know that when you multiply the original matrices with its inverse, you are going to get an identity matrix, right? When you multiply an original matrices with its inverse, for example, when you multiply A, let's say matrix A, you multiply it with its inverse of matrix A, this will give you an identity matrix. So an identity matrix of a 2 by 2 will be your what? 1, 0, 0, 1. This is an identity matrix of a 2 by 2. You also know the identity matrix of a 3 by 3. Meaning, when I multiply this, which is the inverse of that, when I multiply the 2, I'm going to get 1, 0, 0, 1. Right? I still have my x and my y. And this is equals to, now, I need to multiply this and that. When I multiply this and that, I'm going to have 3 over 29 multiplied by 7. This will be 3 over 29 times 7 plus 5 over 29 multiply 19. Right? And then I still have my 4 over 29. 4 over 29 multiply 7 and negative plus into negative 3 over 29 multiply by 19. Right? So this you'll see that it must give us a 2 by 1. The solution must give us a 2 by 1. So now let's get our calculator and see what are we gonna get. Calculator. Let's see. We have 3 over 29. 3 over 29. We multiplied by 7 plus 5 over 29 multiplied by 19. Oh, my mistake. This is not supposed to be there. This is supposed to be there. Okay, 19. So this gives me 4. The first solution is 4. Let's get another one. 3 over 29 multiplied by, okay, this is 4 over 29 here. Don't forget the first solution is 4. And then let's see the second solution. I have minus 3. So my solution is 4 and minus 1. So this side I'm going to have my solution as, okay, let me erase there. And erase there. So that we can have space. This is a nice topic, an easy to understand topic. Okay. So this will give me 1, 0, 0, 1 x, y. This is equals to 4 minus 1, right? And then now I'm going to say 1 multiplied by x is going to give me x. 0 multiplied by y is going to be 0. So x is equals to what? Is equals to 4. And then 0 multiplied by x is 0. 1 multiplied by y, I'm going to get y. Y is equals to negative 1. Right? Y is equals to negative 1. So you can prove this. How do you prove it? You prove it by substituting. You're going to substitute your solution. Let's see. Substituting my solution, I have 3 into, what is the value of x is 4, and then plus 5 into negative 1, then minus 7. I must get my solution is 0. There you go. That's 0, right? And then you need to prove the second one as well. 4 into 4 minus 3 into minus 1 minus 19. Okay. Minus 3 into minus 1 and minus 19. Let's remove that negative at the end. I'm getting 0, right? Another way of proving it is just by saying mode setup and go to equations, which is option 5, equations, right? What are we looking for? We're looking for option 1 because we have x and y. This is x, this is y, then is equals to something, right? So it means we need to take option 1. There. I have 3, I have 5, then my solution is positive 7 because I'm going to transpose it to the other side. It's going to be positive 7. So I'm going to say 7 equals 2, and then 4 minus 3, then this to the other side is going to be positive 19. My first value, which is x, it is equals to what? It is equals to 4. My second value, which is y, it is equals to minus 1. Right? Don't forget to like, subscribe, and share the content with your friends. See you in the next video. Tango!